Next step, at last, is looking at the examples. So from the web page, we can click on the example link, or you find this file inside your CoCoALib distribution, so the one you have on your own computer. So you can find that the HTML documentation, the PDF, which could be interesting to look at, but I suggest you do not print it because it is more than 200 pages. And you should find also the translation table we talked about before. So let's look at the examples. So this page is it's a bit naked, but it is originated by the directory itself containing the examples. This page gives you some reminder of what to do with it and of how to compile things with CoCoALib. So it usually says the suggestion is that you should start from the examples with the number 1, and usually there is the increasing in difficulty in the examples and in richness or in details. So you choose one example, you can compile them all typing make in the examples directory, or you can compile a specific one typing make x bring 1, for example, as we have seen the previous lectures. If you want to write your own program, as we told you, this is just a very compact lines of what we said in yesterday, completely all the lectures yesterday. So when you write your own program, start copying the file examty, call it with your preferred name, like program.c. You write your code in there, you compile it typing make and the name you chose, and you run it typing / and the name you chose. So here you find the list of all the examples in the directory. So it acts as an index for your directory. And in this page, you find this 2 parts of code, which says, which is the short description and the long description that is written inside the examples. So this is actually extracted from there, so that we cannot forget to update it. It is done automatically. So here you have the short description, here you have the long description. So I want to show you, pinpoint just a few of them. One is this one. We mentioned it briefly. We can have computations which are limited in time. So I can have a loop. If I have a function with a loop, that might take forever. And I also have an alternative way of computing the same thing. So I can try running that loop and putting a time limit. And if it fails, then we use the alternative way. This could be interesting. So I thought I would tell you how to find more if you need it. If you want to play, and I'm sorry, no, deep mask. I'm going to talk about deep mask first. Sorry, I didn't write clearly enough for myself. The next I want to tell you is something, again, that might be interesting for you if you want to do some very, very fast code. We saw that you have to be careful when you want to see if 2 power products, one divides the other. This is an operation that we do a lot, is divisible. We did it in the Grosvenor basis computation. And if your program uses this really a lot, I have already told you that you should use an implementation which keeps the exponents. Otherwise, it has to convert from the order vector. And this is another trick that makes it really much faster. So if you have millions of checks of divisibility, then you should investigate this div mask. I just give you an idea, otherwise it seems scary. If you have 3 variables, x, y, and z, and exponents 1, 0, and 3, that means x times z cubed. You can create in a very compact manner 1, 0, 1, which means which exponents are different from 0, and make it very compact inside a machine integer. And then you can compare divisibility of these masks, which tells you where are the holes, and you actually do the test of division if the holes in the 2 power products match. So I think I hope I gave you the idea. Then you might have other refinement, but this was the original idea, and is very effective when you have millions and millions of checks to do. So read carefully, because this says see also this example, because it has a friendly interface, because this is actually the abstract class, but you don't really want to use the abstract class. You want to use it together with a power product. So we made a class which contains a power product and the div mask, and it is so much easier to use than the abstract class for the div mask without having the power product sticks to. So next example I want to talk about is here, X normal form. I talked to you about it yesterday when saying that the normal form algorithm actually is inside CoCoALib distribution. And you see, this is about what we also said yesterday. It's just an example. If you really want to compute normal forms, you should use the library function NF, not the examples that shows how to use the objects. After this could be fun. This is for playing. There are some cryptography algorithms implemented. It just uses the big integers, so it doesn't even use the rings. But you might be amused to play with it. So some examples are even some small investigations that give some little piece of code, which is amusing to play with. Of course, when there are so many examples, one can get lost. So I thought of giving you some hooks for your interest. So next, I will tell you about PP with mask. You see, says this program is very similar to divmask1. The main difference is that this program is shorter and clearer, and it does a proper job of testing divisibility. So you really see the usage of it, and we use it in CoCoA inside our own implementation of the grouping basis. Then we talked about the random numbers, and you find here lots of examples. And so this page is interesting because there are all these examples, and you don't really need to open all the files, because here it gives you what's inside, and then you see which one is the one you want to read, because these are all at the level 1, 1, 1, 1, 1. This is a 2, so it is nice to have an index that shows you what it contains and if it might contain the thing you're looking for. because always a good way of writing some code when you don't know the language well enough is to find an example which does more or less what you want to do. So you take that example and you change the parts that you want to modify. And at the end, this is Bring LM1. We will talk about this in detail. In the next session, I'm going really to open the files and discuss them with you. And so the last thing I want to show you here, the one about C++. So if you are not an expert in C++, you might like to go through all these examples to see what are the different important key points in C++. So there are many examples showing what you can do and how things are done in C++. So I know this quite enough. So next step is to go and see inside the real CoCoALib examples.